As the image continues to gain massive popularity, its ecosystem is also continuously improving today. Let's talk about the ControlNet based on Z Image. Take a look. If we now have a reference image like this, we can extract its depth map. Of course, you can also extract its pose map or its outline map. Then we can use this as guidance to generate a new image. That is the basic usage of ControlNet. This model comes from Alibaba's PAI team. This team is not the original development team of Z Image, but they do come from the same company. Therefore, its quality is guaranteed. Let's look at the introduction to this model. First, the ControlNet image types it currently supports include pose maps, our outline maps, and our depth maps. Also, please note, regarding the ControlNet strength, the officially recommended range is 0.65 to 0.8. Oh, of course, you can test the actual optimal values yourself. We can click on Files and Versions to download this model. This model is quite large, reaching 3.1 gigabytes currently. The official ComfyUI platform already supports this model. We can click on its submission information. Take a look. In the submission made 2 days ago, it already added support for this model. Therefore, if you want to use this ControlNet, you only need to update your ComfyUI to the latest version. I have also built this workflow on RunningHub. You can access this platform through RunningHub. In the ComfyUI space, RunningHub is a fantastic online workbench because whenever new models or new technologies appear, it follows up immediately. You can register for RunningHub using the invitation link in my video description. This way, you can receive 1,000 free points. Furthermore, you will also receive 100 bonus points simply by logging into RunningHub daily. This allows you to try out your own workflows. Since the official ComfyUI site did not provide the corresponding workflow, the workflows we are currently using are various community versions. And the one I am showing you now is the version that has produced the best results in my testing. This workflow is quite unique. From the overall structure, it uses the dual sampler structure found in WAN 2.2. The first sampler is used to generate the composition, and the second sampler is used to refine the composition. Next, let's briefly look at the basic structure of this workflow. First is the model loading section here. We load the native Z Images model. Note that this node is used to adjust the shift. This can be optional. In the original Z Image workflow, this was skipped, but you might consider adding it next. We have our encoder and our PAI. A very important node within this section is this one. This node essentially adds our ControlNet to the main model as a patch. So here, we first need to connect the original Z Image model. Then we load our ControlNet model. This is connected to the modal patch. We also need to connect the PAI, and we have our reference image. This reference image has been pre-gen processed. Take a look. This is the original image, and we extracted its depth maps. There are many ways to generate a depth map here. We use depth anything VC. I set the resolution to VR. To make it more usable, I then resized it, scaling it up to EK resolution. After scaling, we can retrieve its size, the width, and height. We can use this as the resolution for the latent space. At the same time, we previewed the generated depth image. Moving down, we have the prompt section. For the positive prompt, we wrote a woman wearing clown makeup. For the negative prompt, we simply performed a 0 out. We used a total of 8 sampling steps. The first 4 steps are used to generate the composition, and the latter 4 steps are used to refine the image. The sampler we used is Euler, the scheduler is simple, and the CFG is 1.0. The only thing to note about the sampler settings is for the first sampler, we set AD noise to enable, and the one below it is also set to enable. For our subsequent sampler, add noise is set to disable, and the setting below is also set to disable. This setup method is the same as for WAN 2.2. Now let's look at the generated result, a woman with a clown outfit. Take a look. The overall result is quite good. Since it is guided by the depth map, the basic pose and state remain consistent with the reference image. We can generate it one more time. Take a look. This result is still fine. Also, regarding the weight strength, I am using 0.85 here, but using 1.0 is generally not a big problem either. As we just mentioned, besides depth maps, it also supports many other control image types. Let's test a few for you. I have now swapped the processor that extracts the control image. I changed it to AIO, which makes processing more convenient. Let's first look at the first one, the pose map. The overall workflow remains unchanged. Now, let's generate an image, see how the effect is if we use a pose map. When we set the weight to 0.85, the guidance from the pose map doesn't seem to have a major effect, right? Let's generate it again. Take a look. It doesn't seem to have had much impact. At this point, you need to increase the weight a bit. Let's change it back to 1.0. Feel the difference. With a weight of 1, the effect is much more obvious. The pose is fully rendered. This is why we keep emphasizing that you should test the weight values yourself and not blindly follow the official recommendations. Next, let's switch to DW OpenPose. That is the one that includes facial information. Let's run it again. The main difference between DW OpenPose and standard OpenPose is the face. Look here, it includes information about facial key points. Once the face is added, the overall orientation is much closer to our reference image. Based on my testing results, the image quality generated by DW OpenPose is not particularly good. Therefore, if you only need the pose, we recommend using standard OpenPose next. Let's look at Canny. Canny, of course, generates edge and contour information. Therefore, the result looks much more similar to the original person, especially the overall contour. You'll find that it feels more aesthetically pleasing, right? Finally, let's look at head. The effect of head is similar to Canny. Perhaps the contours are slightly stronger. You will notice it has highlight and grayscale parts. Therefore, there may be more details. This covers the basic usage of Z Image ControlNet and the control types it supports. Next, look at some specific applications. If we want to generate more diverse images, we can generally process them this way. Here, I used OpenPose because OpenPose lacks contour information and only emphasizes the pose. This means the composition is more flexible. I also added QwenVL here primarily to help us generate prompts. We want to use the pose from this image and use the basic composition of this image, including the color information. Simply put, our prompt is based on this picture. Let's look at the overall effect. The pose is controlled by the ControlNet input, but the overall image style and composition are actually the same as the reference image used for the prompt. Note, in this workflow, I have set this value to 1 point. Oh, let's generate it again to check its stability. Look, the generation here has a slight issue, but the overall composition and pose are perfectly consistent with what we just discussed. Finally, we tested whether the LoRA we trained is usable when added to the workflow. This is a LoRA I trained previously. This LoRA is essentially a LoRA for this specific person. Let's add it in. The rest of the content is basically the same as the previous workflow. You should note that the weight for this LoRA is currently set to 0.85. and the ControlNet weight is set to 1.0. Let's look at the generated result. You will notice that the character LoRA did indeed take effect, but it is not overwhelmingly strong because I didn't set the strength to 1.0. However, the overall pose remains largely consistent with our reference image. Of course, we can set this value to 1.0 and generate it again. When we set this weight to 1.0, you will notice that the LoRA has a greater effect, and the resulting character looks much more like the one we trained. However, the influence of ControlNet seems to have been weakened. That is why I used 0.85 instead of 1.0 earlier. I believe 0.85 is sufficient to guarantee the pose while also showcasing the basic characteristics of the LoRA character. Naturally, when you use this yourself, you can adjust this weight higher or lower as appropriate. Alright, that concludes our discussion today on Z Image ControlNet. We covered Z Image ControlNet's basic usage, including the types of control images it supports, as well as how we use the QwenVL node to generate corresponding prompts, which combined with our ControlNet, allows the images to have more variation. The generated quality is better. Finally, we also tested the basic usage of LoRA within this workflow. So what are you waiting for? Give it a try yourself quickly, follow me, and become someone who understands AI.